Welcome back to topic 9, which is all about factorable quadratic equations. In this topic, we have our first goal, goal 24, which is all about solving quadratic equations. And then our second goal, goal 25, will bring some graphing into it. And actually, today's lesson 9.2 is going to conclude goal 24. It's a pretty quick unit overall. You might remember that last class we discussed how to solve a quadratic that was just in the form of ax squared plus bx. Both terms had x's. Well, today we're both going to expand that and bring in some old knowledge to make sure that you're keeping up with all the different ways that we have to solve equations, because they tend to blend together and you get confused about when to use one over the other. So let's start with an opener. You have the knowledge to solve every single problem on here. There is one that we haven't quite talked about, maybe two that we haven't quite talked about so far. The other four, though, are definitely doable. So I'd like you to attempt each problem, at least try one step, and then if you get stuck on all of them, or any of them, or some of them, unpause the video and fast forward to the parts you got stuck on. At the end of this page, we're going to do a quick summary of how to solve those 6 types of problems, and then the rest of class is just practice, so it should be a pretty mellow day. Good luck with the opener. Unpause when you're ready. Ready, set, go. All right, and we're back. So hopefully you were able to identify the 4 problems that we know how to solve. But before we even do that, let's see if we can identify the problems that we're going to use SADMAP to solve. Now, ultimately, you will use SADMAP on all of these, but you can't use SADMAP right away. And do you remember what the giveaway is when you can or can't use SADMAP? The giveaway is when you have more than one x in a problem and you won't be able to combine those together. An easy option is like problem 4. We have an x squared and a 6x. You can't combine those together. There's 2 different x's, no SADMAP. Same thing with problem 3, different x's. Problem 2, we have different x's. And then actually, as a heads up, we're going to do problem 5, option 2 without SADMAP as well. So that leaves us with 1 and 5. So let's jump into those 2 and see if we remember how to solve each one. Problem 1 has a single x, which means we're going to use SADMAP, right? Nothing too bad. And before we start, we need to identify how each of the numbers are attached to x. We have this 2, which is, of course, an exponent. We have the 16, which is subtracting. And then we have a 6. And although the 6 looks like it's subtracting from x, it is. The 6 is inside the parentheses, so I'm just going to say parentheses there because we can't get to the 6 until we undo everything on the outside. So where do we start? Well, of course, with the subtracting 16, we just add 16 to each side. My guess is I'll probably need to make 2 columns here. I think these SADMAP problems tend to take up a decent amount of room. So x minus 6 squared equals, and I should have written this better, 16 down here. All right. Once we're here, we've undone addition and subtraction. That brings me down to my exponent. Do you remember how to undo a square? This is topic 7 stuff. It's been a while. We remember that a square root undoes a square. Don't forget your plus minus. This will just leave me with x minus 6 equals, what is the square root of 16? The square root of 16 is 4. And be careful, we don't write plus minus square root of 4. That would mean take another square root. We did the square root of 16. The answer to the square root of 16 is plus minus 4. Once we're here, we still need to solve. And now we can actually get to the 6 that was in the parentheses, and we can undo it with addition. When we do this, I'm going to need that extra space up here. Remember that the 6 is not a like term with the 4, so it just sits either in front or at the end of the 4. I tend to put it right in front of the 4. However, you could have also put the plus 6 at the end. Totally up to you. Do you remember how to find your 2 answers from here? Well, you make 2 different equations, where one equation is x equals 6 with the positive version of 4, and that's 10. The other is x equals 6 with the negative version of 4, and that is 2. Okay, so on problem 1 up here, where we had to go through and there's that single x, it looked something like this, right? All we had to do was follow SADMAP. And I'm going to quickly write down the SADMAP in the order that we would go and what letter we would undo for each one as well. The SA is going to undo the K, and then the multiplication and division is going to undo the A that's out front. Then the next part is going to be the square. And so to undo the square, we're going to do the square root, and we're going to remember plus minus with that square root. Last but not least, we have to tackle the h that's in the parentheses, and that will get us x by itself. All right, the other one I mentioned we could do is 25, because 25 is actually 5 is actually the same as the problem we just did. There's a single x here, so we're going to go through and follow SADMAP. Right, nothing too bad. We are going to have to undo the 16. Again, that's addition and subtraction. We're going to have to undo our exponent, and we're going to have to undo the 25. The 25 is right next to the x, so the 25 is multiplying. Okay, so we will add that 16 to both sides. There we go. Leaves us with 25x squared equals 16. And I will say a lot of my students make a mistake here. And they see that square and they focus in on the square and say, okay, we're going to undo the square next with the square root. And technically you can do that. I'll give you a second option over here, not option 2. This is like option 1.5. And this should say equals 16. But realistically, if we're following SADMAP, you should divide by 25 first. And I think maybe they're hesitant to do this because the fraction 16 over 25 looks scary. But remember, it's just the fraction 16 25ths, right? If you have 25 cookies, someone ate 16 of them. Then we can undo the exponent. When you undo the exponent, we do that square root, and that's going to give us x equals, don't forget your plus minus like I did, awkward. We just do the square root of each part. The square root of 16 is 4, square root of 25 is 5. And that's it, right? No harder than that. Now, if you had done this on your calculator, that's fine. You would get a decimal. And then when you took your square root of the decimal, you would get this as well. You'd be getting 0.8 each time. But either way, the fraction wasn't too bad. Now, I mentioned there is a second option, and I'll show you what my students tend to do and how you can actually do it correctly. They skip right to the exponent, and they say, I know I have to undo the exponent, so they throw in a square root. And they're somewhat right. But then, here's the mistake. See if you can spot it. They say 25x equals plus minus 4. What did they do wrong? Well, they forgot to apply the square root to the 25. So realistically, what they should be doing is they should be distributing that square root to both the 25 and to the x squared, and of course to the 16 on the other side. And so then that would give them 5x equals plus minus 4. And can you see how you'll end up with the same answer now, dividing by 5? So this way is doable, but I don't suggest it because I think you might as well follow the process. It's the same number of steps, just in a different order. Please don't forget also, you are allowed to distribute square roots and squares, any exponent, right? As long as you have addition and as long as you have multiplication and division. These were attached by multiplication, so distributive property was a go. These were attached by division, so distributive property is a go. So what do we do when we get to something like this? You just use SADMAP. Right? Nothing too bad. And there's only 3 things we have to undo. The first thing you're going to want to undo is the C. The next thing you want to undo is the A. And then at the end, you want to undo the square using a square root. And that's your plus minus notation. Okay, let's take a look at these last couple. Now, are there any problems on here which hopefully you felt confident on? There should be 2 in particular that we just did last class, 9.1, that you'll be all right with. You looking at problem 2? You should be. Because problem 2 is already in what we call factored form. And although you can't use SADMAP from here, last class we learned the zero product property, which tells us if you just have x's multiplying times each other as factors, then the zero product property applies. Technically, there's a 2 out here as well. So what we would do with each of these is you would take each one of these guys, and you would say if they're going to multiply to equal 0, then one of these has to equal 0. That's the only way you multiply to get 0. However, we also learned if you take this coefficient, this 2, and set it equal to 0, 2 is not equal to 0, so that means that there's no solution for that. In fact, we usually just say you can ignore the coefficient. So let's finish solving the rest of these. adding 2 to each side. So now we're using SADMAP, right? We have equations that only have a single x. And so now we finish solving using everyone's favorite method, just undoing what is attached to x. Last step, divide by the 2, and we end up with a very pleasant fraction, negative 1/2, or negative 0.5 if you'd like. Right, so we can't use SADMAP initially, so we break it into smaller equations that only have one x, and then use SADMAP. So just quickly summarizing what we did here, we took x minus p equals 0, x minus q equals 0, and then SADMAP. Easy peasy, right? All right, moving on to our next problem, the other one that we should have been comfortable with, and that is, of course, number 4. And the reason 4 is comfortable is because we spent quite a lot of time on it last class. We talked about 4. It's not in factored form. You have 2 different x's. But we said we know how to put this in factored form. We saw what each of these had in common. And they each have an x in common. So we're going to factor out an x from each of those. Instead of x squared, now we just have an x. Instead of negative 6x, it's just negative 6. And then we have our 2 equations. X equals 0, or x minus 6 equals 0. First one's already solved. Woo! Second one, we have to do the arduous and terrible step of adding 6 to each side. But that's that. Okay, again, not too bad. Reminder, though, what we really had to do on 4 is to put this into factored form. And one way we know to put it in factored form is to find what they have in common. And they each had an x in common. Now, that gets a little bit trickier depending on what other terms are in that problem. But in a situation like this, as a reminder, you would just take x out of each. That would leave you with ax plus b. And then make 2 equations. X equals 0 will already be solved. Ax plus b equals 0. You need to use SADMAP. And there we go. But this falls apart a little bit when you get to something like problem 3. Because on problem 3, if you wanted to apply that same idea, in fact, it's a very similar problem, right? X squared minus 6, but there's this extra negative 16. So I'm going to erase this, but one thing you can't do is you can't take an x out of each term. You can take it out of x squared, you can take it out of 6x, but there's no x to be had in the 16. And so we can't say that there's a greatest common factor of x. In fact, none of these have something in common to all 3. There are also 2 different x's, so we can't use SADMAP. So what do we do? Well, if you have 3 terms and it looks like nothing's in common, is it not possible then to put this into parentheses? But wait, didn't we just spend like 6 lessons in topic 8 learning how to put a trinomial in factored form? How did we do that again? Oh, right, that was our box method, wasn't it? Right, remember that box method? I told you, you're going to be really doing this box method pretty much every class for the rest of the semester. So, box method wise, just a friendly reminder, x squared on the upper left, negative 16 on the lower right. We need to split apart the negative 6x. There we go. So my 2 numbers need to add to make negative 6x. And they also have to multiply to equal the multiplication or the product of the other diagonal. So what adds to make negative 6 multiplies to make negative 16? I'm thinking negative 8x and 2x is a pretty possible combination here, right? Negative 8x, positive 2x. I think that works. So let's find the outsides. We know x squared will just have x and x on both sides there. Negative 8, positive 2. In fact, if you remembered back from topic 8, because there's a 1 in front of this x squared, we didn't even need the box. We just needed these 2 numbers. And then we could go through and say, once we know those 2 numbers, it's x minus 8 and x plus 2. So now, hopefully, we finally understand why factoring is so useful to us. It allows us to be able to solve a whole new class of equations. These trinomials, these ax squareds plus bx plus c's, it put this into factored form where we have 2 factors and each factor has an x. Once we're here, the rest is pretty darn easy, right? X minus 8 equals 0, or x plus 2 equals 0. And then finish solving. Can you see that you would add 8 to each side? Gives you x equals 8. Or subtract 2 from each side, x equals negative 2. And that's that. So if we look at problem 3 down below, ax squared plus bx plus c, there's a couple steps. My first step is use the box to put into factored form. And as a reminder, our factored form will be those two sets of parentheses to equal 0. And then our second step is that 0 product. I totally misspelled product. That was awkward. Product property and SADMEP to solve. So we would take one equation, set it equal to 0, or the other equation, set it equal to 0, and SADMEP solves it out. It's all coming together. But I think we still have one blank box left, don't we? This ax squared minus c that we have up above here. And the reason why is because although we can solve it using SADMEP, there is another way that's maybe equally as fast, maybe even faster, depending on how good you are with your factoring. You might recognize this as a difference of squares. Do you remember that from factoring before? When we had something with an x squared and something without an x. Right? They don't have an x in common, but we know how to put this into factored form super quickly. We know that one will be positive, one will be negative. And to create this 25x squared, think about the square root. That would be 5x times 5x is 25x squared. What times itself is 16? 4 and 4. Now, if you wanted to very quickly check this, it's easy enough to do. I'm just going to make a box and look at the outsides. 5x with a positive 4, 5x with a negative 4. And when we multiply, 25x squared minus 20x, 20x minus 16. What happens? Does that match what we started with? Well, I think it does because our 20x's cancel, don't they? That leaves you with your 25x squared minus 16. So that's the nice part. If you don't see that middle term, it means they canceled, and the only way they cancel is one positive, one negative. Then to solve, 5x plus 4 equals 0, or 5x minus 4 equals 0. Subtract your 4 here, add your 4 here, divide by 5. Negative 4/5 or 4/5. Is that the same answer that we got as option 1? See it over here? Well, certainly. Instead of just writing in the condensed form, we saw the two answers separately. And so, this gives us our last option, factor, say difference of squares. And so that gives me something like this equals 0, and then SADMEP. All right, so we have really 6 possibilities, maybe 5.5 possibilities, of how to solve problems. So you may have noticed that problem 3 was something that technically we had never solved before, but by combining our knowledge of factoring, topic 8, with the 0 product property, we were able to isolate x. So all we're going to do for the rest of today is just practice solving for x. Our first set of problems are going to be done with one partner. And this first set is going to be that ax squared plus bx plus c type of problem. We can see this right here. So we're going to be putting them into factored form, lots of box practice, and using that 0 product property. As a reminder, there's a couple steps here. The first thing you're going to need before you even start to factor is you need to make sure that your equation equals 0. If your equation doesn't equal 0, you need to do that first, and we did that last class. And then second, you are going to factor with the box, or without the box if you're very confident with factoring. Once you're done with that, call your teacher over, we'll check your work, and we'll send you on to the next page. Okay, so as we go through and solve each of these, you need to realize that you could use a box every single time. However, I'm going to try to do all of them without the box method because I think it's a little bit quicker. And there might be one or two where I'm like, oh, we should use the box here. But I'll try to give you a little visual of what I'm thinking of as I do those problems. So let's begin. Problem 1. As with all of these, there are two different x's, no sad map yet. We need to factor. So when we factor, we should notice there's a 1 in front of x squared, which is great because we can use our shortcut. I need two numbers that add up to make 6x, but also multiply to make 8x squared. And those two numbers are, of course, 4 and 2. Normally you'd put x's if you're using the box, but because there's just a 1 there, we can skip right to our factored form, x plus 2 times x plus 4. Sweet. Once we're in factored form, the last step is pretty easy. It's our zero product property, right? X plus 2 equals 0 or x plus 4 equals 0. Now we're back to sad map. Shouldn't be anything too bad. We subtract 2 from each side, subtract 4 from each side, and we're set. Again, going from here to here to here is just that box method, so you should check back to videos like on topic 8, maybe 8.8, 8.9, something like that for some extra review, but you should also be able to do this in your head at this point. It's just going to be more efficient. So let's keep going. Problem 2. You might look at these and say, ooh, there's only two terms here, x squared and x, so we can take out an x from both of these. And although you're right, now we have x times x minus 1 equals 12, and so we can't use the zero product property because the zero product property is so named if things are multiplying to equal 0, and this is 12. If you don't have a 0, but you have two different types of x's, then you want to put everything on one side and make the equation equal to 0. So first step, let's subtract off that 12. This was a trick that we did last class, and it allowed us to get the equation equal to 0. Notice the minus 12 is not like terms with the x squared, nor with the x, so it just sits with it. I'll put the 1 here. There's a 1, so we can use our shortcut. What adds to make negative 1, but also multiplies to make negative 12? Well, I think that's going to be negative 4 and positive 3. Does that seem to work out? I think so. So this becomes x minus 4 times x plus 3 equals 0. From here, two equations. You know it. And each of these are going to end pretty much the same way. Add your 4, subtract your 3. Nice. Third problem, 3x squared plus 4x minus 4. Now on this one, we unfortunately can't use that same shortcut. You could use the box, but don't remember you can also do some nice mental factoring here, right? I know that the first two numbers, and I'll show in green, have to multiply to equal this 3x squared out front. And I know that the last two numbers are going to have to multiply to equal the number at the end. Because we're only dealing with nice whole or integer numbers here, no fractions, no decimals, 3x squared is pretty easy. Has to be 3x and x. There's no other way that we're going to be able to multiply that. You could use negatives. Typically, we keep them positive. Then to get negative 4, we do have a few options, right? We have negative 1 and positive 4. You could also switch that, 4 and negative 1. Or you could go with negative 2, negative 2 and positive 2, or the other order. So that's 2 and negative 2. 4 combinations. I see 4, which is a pretty big number, but not too big. I think if I put a 4 in here, 4 times 3 would give me 12. That's much too big. I think it's going to be a 2. And 2 times 3 is 6, minus 2 is 4. Yeah, I think this is going to be it. So again, if you can't do that in your head, that's fine. Just use the box method. It'll get you there each time. And from now, we have our two equations. A little bit of mental math. The second one is easy, negative 2. First one's a little more challenging. We have to add 2 to each side first, and then divide by 3. And so we end up with 2/3, or please don't put 0.6. 2/3 is not 0.6. You could do 0.666. You could put the repeating, whatever sounds good to you. Okay, problem 4. This is problem 4, but we're not equal to 0, so we know how to deal with that. We subtract our 3x from each side, right? Something like this. There we go. X squared plus 2x minus 15. And now there's the 1 in front, so factoring becomes pretty easy. What are two numbers that multiply to equal negative 15, but also add to make 2? It's got to be some combination of 5 and 3. There aren't too many numbers that multiply to make 15, and I think the 3 has to be negative 5 minus 3 is 2. X with a positive 5, x with a negative 3. Two equations, and finish solving. The question I get pretty often here is how much work do you have to show? Because people will start to say, well, x plus 5, I know then the answer is going to end up being negative 5 because you just switch this inside number. But you don't always, right? On this problem over here, I didn't just switch negative 2 and say the answer was positive 2. There was a 3 involved. We always ask you to show a setup and an answer. So if you look through here, I have a setup, another setup, you can consider that the answer, a setup, and an answer. So you should really focus on showing all of these steps. You can show more if you would like. Of course, you could show subtracting 5 from each side, but you really shouldn't show less. A setup doesn't take us too long. All right, let's keep on moving. Don't want to be here all day. Okay, we're definitely not equal to 0 here, so let's add, this is an invisible 1, so let's add 1 to each side. Invisible 1 up here as well. These cancel as it should. It becomes 2x squared. And then we subtract 4x from its like term over here. That gives me negative 1x. And the negative 3 has nothing to subtract with, so it hangs out. Okay, once we're here, we should be able to go through and put this into factored form. It goes pretty quickly. To make 2x squared has to be 2x and x. To make a 3, I don't want to put a 3 here because 3 times 2 is 6. It eventually has to become a 1. That's way too big. I think the 3 has to be here, 1 has to be here. This is 2, this is 3, looking good. Positive 2 minus 3 should get us there. And then we solve. 2x minus 3 equals 0, or x plus 1 equals 0. It means x will be negative 1. Let's see, 2x equals 3. I think that means x equals 3 halves, which is different than what we got earlier. That is 1.5, right? Earlier we got 2 over 3. 3 over 2 is different. Problem 6. Problem 6 initially looks like there's a 2 in front of x squared, which makes it a little trickier to factor. But then I might notice that there's actually a 2 common to all of these. So I'm actually going to take out that 2 from each of these first by dividing it or factoring it out. And that should give me, yeah, look, now we have that 1 in front of x squared, so I think that makes the factoring much easier. What multiplies to make 24 adds to make 10? I've seen this one. This is going to be 6 and 4, or 4 and 6, doesn't matter. When we use the zero product property, I'm not going to bring the 2. 2 is never going to equal 0, so we're just going to focus on x plus 6 equal to 0 and x plus 4 equal to 0. And you end with negative 6 or negative 4. Now sometimes we get asked here, well wait, what if I didn't realize a 2 was in common and I went and I used the box? I did 2 times 48, that's 96, and I went through and figured that out. My factors are different. Well, they're not that different. What ends up happening if you don't take the 2 out is one of your factors will be 2x plus 12, or that 2 might have been distributed to this guy over here, and so one of your factors might have been 2x plus 8, right? Those are your only options. But no matter what, when you make your two equations, you'll end up getting the exact same answers. All right, continuing on through. Let's see, there's that invisible negative 1. Oh, there's this 1x hanging out over here. Let's get rid of that. Subtract it from both sides. You'll notice that there is nothing like the negative 1x, so we should probably just write them all next to each other in standard form. So I put the negative 1x in the middle. Now again, there isn't a positive 1 hiding in front here, but that's okay. I'm just going to divide everything by a negative 1 and see what we get. This gives me positive 1x squared plus 1x minus 2. And then we end up with 2 sets of parentheses. What multiplies to make 2 adds to make 1. We know it starts with x and x. There has to be a 2 and a 1. That's the only way to make 2. And to get a positive 1, I think the bigger number will need the positive. 2 minus 1, yeah. So this gives us two equations. X minus 1 equals 0. I'm going to do the OR down here. X plus 2 equals 0. Notice I didn't need the -1. And many of you might not have realized you could take out the -1. You can. You might have used the box method. Great. The -1 will be on the inside. You'll still get x equals 1 or x equals -2. Last one for this page. 9x squared minus 16 equals 0. Not as bad as you think. They asked you to factor, so we're going to put this into factored form. And we do need to recognize that this is a difference of squares. So if it's a difference of squares, we take our square roots. Square root of 9x squared is 3x and 3x. To get a negative, we'll need a positive negative. Square root of 16, 4 and 4. From here, two equations. 3x plus 4 equals 0, or 3x minus 4 equals 0. And then we start solving. 3x equals -4, which means x equals -4/3, or 3x equals 4, so x equals +4/3. And it's totally fine to leave it like that. Don't forget on the test, a lot of times if you get the same answer, one negative, one positive, they'll put them together just to save time and space. All right, so we've gotten some great practice now on our factoring and using that zero product property to solve. But we don't want to forget what's come before. So if you take a look at our third page is going to show us equations that only have a single x. Now, when you go through and you solve this with this single x, you are just using SADMAP to isolate everything. Now, you're using SADMAP, right? We've actually done many of these problems before. So if you go back to my YouTube channel and you look back at topic 7 on solving these equations, right? Solving quadratics in HK form. And I think this is something like lesson 7.4. If it's not, I'll put it in the comments. We do all of these problems. They're the exact same problems all the way through. I wasn't too creative in terms of coming up with them again, but it's also been a couple months since you've seen them. So get the practice in again. I've given you the answers on most of them as well. If you're not sure how to do it, I'm not going to re-record myself explaining how to do them. You can go back and take a look, and you should be fine. So try those problems. Once you're done and you've checked your work, unpause, and we will move on to the last page. Ready, set, go. All right, last page. This one we are going to go through. So if you're working in partners, find a new partner. Always good to try and make new acquaintances, practice our social skills. Each of these problems fits one of the types of problems on the first page. However, I'm not going to tell you which one, so you're going to have to use all your different moves, your algebra moves and skills, to figure out how to get x by itself. So, without further ado, you guys should get started, and then come back together, and we'll see how you did. Ready, set, go. Okay, well, let's look at our first one. This to me looks like it's already in factored form, which is great. Two equations. We're doing wonderfully. Add 1 to each side. Add your 3 to each side. Divide the 2 that's still attached to the x. 3/2 or 1.5. Nice. All right, problem 2. X squared plus 28 equals 11x. I see two different types of x's, so no SADMAP here. We need this to equal 0. We'll start by subtracting our 11x from each side. X squared minus 11x plus 28. Very important to write this in standard form before we factor. And I think in terms of factoring, actually, this one's pretty easy because it's just plain old 1x squared. X and x. What multiplies to make 28 adds up to make 11. You might say, ooh, 4 times 7 is 28, but 4 plus 7 is positive 11. Let's make them both negative. Negative times a negative is a positive, but adding two negatives together keeps it negative. Two equations, x minus 4 equals 0, or x minus 7 equals 0, and we finish solving. 4 and 7. Next up, problem 3. I only see a single x here. Well, that's nice. I'm actually going to show you how to do this in two different ways, but yeah, there's only a single x here. So I think then we could probably just use SADMAP, right? If we think about SADMAP, we need to analyze what's attached to the x. Okay, it looks to me like there is certainly an exponent, no surprise there. There's a 2 out front of the parentheses, which means it's multiplying. And then there's this 1 inside the parentheses, so we get to that at the very end. Looks to me, based on this, we start with undoing multiplication with division. So let's divide both sides by 2. 2 divided by 2 cancels. Leaves us with x minus 1 squared equals 0. 0 divided by anything is 0. So we've taken care of that. We're on to the exponent. So square root of each side. Leaves me with x minus 1 equals, don't forget that plus minus square root of 0. Well, what times itself is 0? 0. Plus minus 0. And we're good so far. Last step, we add 1 to each side. Now, you might be asking, what the heck is plus minus 0? Well, plus minus 0 means we are either doing 1 plus 0, which is 1, or we are doing 1 minus 0, which is also 1. Plus minus 0 is the same number. Positive 0, negative 0, it means the same thing. So there are two answers here. They're just both the same answer. Now, I mentioned there's a second way you can do this, and this doesn't happen too often. I'll show you on another problem later on. But we have a square, which means x minus 1 is being multiplied by itself. And if you write it out like that, can we see that the x minus 1s, we're now in factored form? We could take x minus 1 equal to 0, x minus 1 equal to 0, and solve. 1 and 1. You don't have to write both of the answers on a test. You would just see x equals 1. But don't forget what a square means, and that's kind of a clever little connection there. All right, problem 4. 2x squared and 8x. I see two different types of x's, so as before, we want to make sure this equation equals 0, and we're old pros at this point. Okay, 0. We have 2x squared minus 8x equals 0. Now, you're looking at this going, well, wait, usually we have a third term when we use the box, and you're right, this is actually from 9.1. I think we can just take an x, or a 2x if you'd really like, out of this. So I'm going to take the, I'll just do an x for now. Gives me 2x minus 8 equals 0. And then two equations. X equals 0, or I'll use the space over here, 2x minus 8 equals 0. Add 8 to each side, divide by 2 to get 4. Nothing bad. If you had taken that 2x out instead of the x, you would have still gotten 0 and 4. Okay. Fifth problem, x squared minus 81 equals 0. This one just has so many ways to do it. I'll remind you of two different ways though. One way is SADMAP. There's only a single x here. Not bad at all. So, sorry, that was my dog running into the closet and getting stuck. We can go through and just add our 81 because the 81 is subtracting, and we have our exponent down here, right? Exponent 81. There we go. And if we add 81 to one side, we better do it to the other. This leaves us with x squared equals 81. And we took care of that. No addition, subtraction. Now we undo the exponent with our plus minus. What is the square root of 81? What times itself is 81? That's 9. And so we end up with our two answers, positive 9, negative 9. A lot of times you'll see these braces when there's more than one answer. You totally don't need to put them. We'll know what you mean either way. I did mention there were two ways to do this, though. Don't forget this is also very factorable. This is our difference of squares. X minus 9 plus 9, and then two equations. X minus 9 equals 0, or x plus 9 equals 0. Add 9 to each side, or subtract 9 to each side, and look, we got the same answer as before. Okay, just a couple to go. Let's try 6. 6, well, we have an x squared and an x, so it looks to me like we can't use SADMAP yet, but we at least can add 6x squared to each side. 6x squared, very exciting. Standard form, let's see, 6x squared minus 52x minus 18. Well, I would say that we could go through and divide out something. Oh, we can take a 2 out of all of these, can't we? Let's divide everything by 2. Otherwise, those numbers are way too big. If I couldn't reduce anything, I would have gone through and used the box here. Seriously. 3x squared minus, this looks like 20, not 27, 26x minus 9 equals 0. And 26 has 13 and 2, no other factors. Okay? Well, we should probably go through and factor this. You can use the box or not. I'm going to guess and check and hope I get there. 3x squared is pretty easy. 3x and x. To get to 26, I think we need a 9 here. 9 times 3 is 27. That's really close to 26. So this has to be a 1. To get a negative, I think we'll put a negative on the bigger number. It's like a positive. This is negative 27 plus 1, negative 26. Cool. We need 2 equations, so we end up with 3x plus 1 equals 0, or x minus 9 equals 0. X minus 9 equals 0 isn't bad. Add 9 to each side. I'll use some more space for my other equation. Subtract 1 from each side, and divide by 3. All right, 2 to go. X squared plus x plus 1 equals 0. Okay, well, let's go ahead and put this into factored form. We're already equal to 0, which is nice. I'm going to need, there's a hint up here. That seems weird. We're going to figure out what adds to make 1x and what multiplies to make 1. You can do 1x squared if you'd like. It's actually a little tricky here. 1 times 1 is 1, but 1 plus 1 is 2. 0 plus 1 is 1, but 0 times 1 is 0. I can't think of anything, actually. 1 only has itself as a factor, 1 and 1. So what happens here? Well, the answer is we don't know how to factor this. We don't know how to factor. And I'm going to say with using quotes, nice numbers. When you guys get to Algebra 2, and actually even in our last topic, Topic 10, we will talk about a couple other ways that we can solve equations like this. And it turns out you can factor with fractions and decimals and square roots as well, but we're not really covering that right now. So at this point, we don't have a way to solve this. And so my solution is, I don't know. There is a solution here, so don't just assume that if this happens, it means no solution. There is a solution. We just don't know how to get there so far. Now, we're not going to give you anything like this on the test, but it is good to remember that there are lots of equations out there that we won't be able to factor. Okay, last one. X minus 4 times x plus 3 equals 18. Well, this presents a bit of an issue because in order to use the zero product property, what does the equation have to equal? It has to equal 0. So you might be tempted to say, well, let's just subtract the 18 from both sides. I'm going to erase this shortly so I don't do too much. Well, that would give me x minus 4 times x plus 3 with a minus 18 at the end. Those aren't like terms. The 18 can't combine. Then can we make multiple equations? Well, no, sadly we can't, because the only time the zero product property works is if everything on the one side is multiplying. As soon as you have addition and subtraction, we're going to have a bad day. But wait, there is actually something we can do. I'm going to multiply everything out here first and hope we get lucky. So x times x is x squared. X times 3 is 3x. And then I'll do negative 4x and negative 12. There's still the minus 18 and still the 0. Let's combine like terms. There's nothing to combine with the x squared, but 3x minus 4x is negative 1x. And negative 12 and negative 18 are actually like terms with 30. Hey, look, now I have a trinomial equal to 0. Can we factor this? You might say, why would we factor? That's just going to be what we started. But are you sure? Let's try it. What times what gets you 30 and adds to make 1? Well, seeing this negative here tells me that whatever they add to, they're going to be 1 apart. So what are the factors of 30 that are 1 apart? That's 5 and 6, isn't it? 5 times 6 is 30. And if you do positive 5 minus 6, you get negative 1. You'll notice by putting this negative 18 into the equation, it makes our equation factor differently. And so now we have two equations. X plus 5 equals 0, or x minus 6 equals 0. Adding 6 to each side, subtracting 5 to each side, and we're set. Now, problem 8 is a pretty challenging question. I can't guarantee we'll give you anything like that on the test, but maybe as a bonus problem. But the rest of these, hopefully you found some success or at least some confidence of how to look up how to do each problem. Just a friendly reminder, anytime you see a single x, SADMAP. If you see multiple x's, hopefully things will already be in factored form and you can just solve. But if they're not, use the box or do some mental factoring and then solve from there. So thank you for tuning in. This is really going to conclude 9.2, how to solve quadratic equations using factoring. And I'm excited to have you back for 9.3, which is all about graphing. Thanks again, and see you soon.